Today, we will discuss about water jug problem. The problem definition is that there are two jugs, one with a capacity of 4 gallon and another with a capacity of 3 gallon. None of the two jugs has any measurements or markings on it. We can use the pump to fill the jug. The problem is that we have to fill exactly 2 gallons of water in the 4 gallon jug. Before discussing about this problem, we should know about what is the state space of a problem. State space is a representation of all spaces that contains all necessary information about the states. For example, consider a man who wants to visit two cities, A and B, and reach his final destination, that is his home. So, the man starts from his initial position and chooses either A or B first. Suppose if he visits the city A first, then he visits B next and finally goes to his home, which is the goal state. Or if the man had chosen the city B first, then he will choose A next and finally visits his home. Such representation of all possible states of a given problem is called state space of the problem. Now let us describe the state space of the water jug problem. State space can be described as an ordered pair of integers x, y, where x represents 4 gallon jug and y represents 3 gallon jug. Thus x takes a value 0, 1, 2, 3 or 4 and y takes the values 0, 1, 2 and 3. The initial state is 0, 0. That means no water is available on each jug. The goal state is to get 2 liters of water in X jug and can have any amount of water in Y jug. To solve the water jug problem, one needs to define the production rule. The production rule is of the form A implies B, where A is the applicability of the rule and B is the operation to be performed. Let us see how to write production rules for the water jug problem. The first rule is if x is less than 4, that is if x has some space to fill in water, then the x jug can be filled with 4 liters of water and the y jug can have y amount of water. The second rule is if the amount of water in the y jug is less than 3, then we can fill the 3 gallon jug and the x jug can have x amount of water. The third rule is that if the amount of water in the x jug is greater than 0, that is x has some amount of water, then we can pour some amount of water out from the 4 gallon jug. Thus, the leftover water in the 4 gallon jug is x minus d. Similarly, the fourth rule is that if we pour out some water, say d amount from the 3 gallon jug, then the leftover water will be y minus d. The fifth rule is that if the amount of water in the first jug is greater than 0, then we can pour down all the water on the ground. As a result, the amount of water in the first jug becomes 0. Similarly, the sixth rule is that we can pour down all the water from y jug. As a result, the first jug contains the same x amount of water and the amount of water in the second jug becomes 0. The seventh rule is that if the total amount of water in both jugs together is greater than or equal to 4 and also y has some amount of water, that is y greater than 0, then pour water from the 3 gallon jug into the 4 gallon jug until the 4 gallon jug is full. Thus, the first jug contains 4 liters of water. There was initially 4 minus x space empty in the x jug and this is the same amount of water we filled in x. Initial amount of water in y jug was y Hence, y minus 4 minus x is the leftover amount of water in y jug. Similarly, the eighth rule is that the second jug contains 3 liters of water. There was initially 3 minus y space empty in the y jug. Initial amount of water in x jug is x. Hence, x minus 3 minus y is the leftover amount of water in the first jug. The ninth rule is, if the total amount of water is less than or equal to 4 liter, then x plus y water can be filled in the first jug. Similarly, the 10th rule is, if the total amount of water is less than or equal to 3 liter, then x plus y amount of water can be filled in the second jug. The 11th rule is, if 0 is the amount of water in the first jug and 2 is the amount of water in the second jug, then we can pour down all the water in the second jug. The last rule is, if 2 liters of water in first jug and y liter of water in the second jug, then we can fill the second jug and empty the first jug. For the water jug problem, there are several sequence of operators that will solve the problem. Let us see one of them. The initial state is 0, 0. When applying rule 2, we get 0 and 3. When rule 9 is applied, we get 3 as well as 0. Again, if rule 2 is applied, we get 3 as well as 3. When rule 7 is applied, we get 4 as well as 2. And when rule 5 is applied, we get 0 as well as 2. And finally, when rule number 9 is applied, we get 2 liters of water in the 4 gallon jug and 0 amount of water in the 3 gallon jug.